All right, just welcome to the Lōkahi Innovation Healthcare Hackathon. This is probably, from my perspective, one of the strongest business cases we've ever had in a long time for hackathons. So I'm excited about that. If you have a good technology piece and you have a strong business case, you have the opportunity to do well. And so that's what we want to do. Thank you all, everyone, for joining and for volunteering. This, once again, is a very important, not just your typical hackathon, but really important because it deals with cancer and basically finding cancer solutions. And so we'll walk through the whole presentation that I worked on during the semester, and then what we're doing, we're refining and coming up with new ideas and packaging it all into a product for the competition. We have 5 members. It's a full team, which is great. I love full teams, and I've run a lot of them. And over the years or so I've been doing this, I've gotten more organized. So you'll see that Taha, Hamad, who's been on a few, it's a little bit more organized now. So basically what we're building here is what's called a clinical decision support system. And so with AI, you have the ability, you have like human intelligence in a box. So you have the ability to do things you've never been able to do. So as we get into this, let's first do some introductions, and then we'll get right into the project. So go ahead and just introduce yourself. Hamad, you can go ahead and start first and introduce yourself, say a few words, and then we'll move on. And if you have problems with the speaker or anything, just go ahead and type it into the chat because I am watching the chat as well.
All right. How are you, Michael? I'm Ahmed.
Doing very well. Good to see you. Salam alaikum.
Walaikum salam. That's a long time. I was actually busy with my graduate studies, and now I am graduated from the university with a Bachelor of Computer Science.
Congratulations. Very good.
Yeah, thank you. Yeah, except my congratulations that you have been accepted to a PhD degree, and now you are pursuing your quantum. Am I right? The PhD in quantum, right?
Working on my PhD in quantum AI, yes.
Yeah. So a little introduction of mine. Like, I'm Ahmed from Pakistan, and I have been working with Michael for a couple of projects. I took a break in between due to my graduate studies, but nowadays I'm available for everything since I'm planning to move abroad to do my PhD in AI. So I'm just finding some ways like how to go abroad, like what are the different ways in which I can get into admission. So that's a bit from my side. So thank you, everyone.
Thank you, Hamad. Good to see you again. Very glad to see you. Congratulations on your studies, and I'm glad you're part of the team today. I'm so excited about this project. Okay, I'm
Thank you.
Anula. Amanullah, would you like to introduce yourself real quick?
Hi, sir. How are you?
Very good. Welcome to the team.
Thank you, sir. So basically, I am a learner, a new learner, and I have done a little course of data science, and I have good knowledge of about models and algorithms. So yes.
Well, it's a good place to learn. Hackathons, I think, are the best place to learn about generative
Sir,
AI. Yeah.
honestly, sir, it's my first hackathon. So I appreciate if I uh, get some suggestions and tips.
No problem. We'll give you lots of suggestions and tips. Welcome aboard. It's a good place to start. Hackathon's a great place to learn about generative AI.
Thank you, sir.
Anjali, you're welcome. Thank you for joining the team. Anjali, go ahead and introduce yourself real quick.
Yeah, sure. Are you hearing me?
Yes, I can.
Okay. Hello, everyone. My name is, as you can see, Anjali, and I have done computer science. It's been a year that I have graduated, and I have Python experience, and I have already attended 5 hackathons before, and I am really excited about this one too.
Excellent. Anjali is a professional. She's done 5 hackathons, so we're in the presence of greatness. This is good. Good. Okay, Rina, why don't you introduce yourself? I haven't seen you in a long time. Welcome to the team. It's good to see you again.
Hello, Mike. How are you?
I'm doing well.
Hello, everyone. I am Rima Mehmet from Pakistan. I have a strong skills in AI and Python. I have experience with hackathons. Like I have already worked with Mike as well. So this is my introduction.
Excellent. Good. And it's great to have you aboard again. We're definitely good to see you again. So once again, guys, we have a great hackathon coming up here. I don't see anyone else to admit. I think we have one person that's missing. we will continue with the presentation, okay? And we're going to go through everything today. I've sent you this morning, I sent you a sheet of stuff so you can actually get started on your project, and we're going to make assignments today, so it should be pretty fun. All right, just once again, starting back at the beginning, we are working on a clinical decision support system. And with AI, you got human intelligence in the box. You can attach that intelligence to anything. And as a result, you can really just do some incredible stuff. Guys, I run my projects on something I call the 5 C's, and that's communication, concept, components, configuration, and completion. So you really want to walk in with a strong communication system. Most of our, if not all of our communication will be on LinkedIn, Zoom, and then you'll use a Discord for just posting that we had worked together as a team so they could see some documentation. The next thing is concepts, and we're coming with a really strong concept. This is work I did over the semester and cancer treatment for breast cancer. It's got a great business case, and what we're going to be doing is we're going to be further developing that, enhancing it, and coming up with new ideas. And that's what's so important now. I think someone mentioned there a Python program. I am too. I can write now with generative AI. I can write 4,000 lines of code on the weekend. And so it's not really coding is not the issue anymore. All this coding you need to do could be done very rapidly. What it is, ideas and concepts. So if you're working through your assignment and you just come up with this brilliant idea, that's what we want. That's what's valuable. Your ideas. Okay, it's much more valuable than the coding these days. Coding is important. We're going to do coding. Ideas, if you come up with something new, so a way I didn't see, or you come up with something that's great, make sure you make this is concept. This is what's the brainstorming part that you're doing this part 2 right here. This part is you start building technology. This is the fun part. You start coding, you start building things, pieces here, pieces there, and it's like you're throwing everything out on the table. It's like a big puzzle. All right. So you build a puzzle piece. I think I can build this. I can do this. I think I can build this. So just kind of flowing ideas. And now with generative AI, you can just build so rapidly. And then from that, once those components are kind of built, you kind of, well, what's the project? I said, this is the configuration stage where you maybe come up with a new idea. This is the ha-ha moment. This is the moment before the play, right? The moment before the storm. You come with this brilliant idea that you didn't think about before, and you start taking all these pieces and you start putting it all together, all right? And then this completion is so important, all right? You can do all this great work, but if you don't get it into the project, if you don't make the timeline, then it's going to be very sad. And there's a few projects I missed. I haven't missed a lot, but there are maybe 3 or 4 that I had done all this work, and for some reason, I didn't make the timeline. And you're sitting there just going, wow, I did all this work, and I didn't get to show it. So it's very important that we hit that completion, that we hit that timeline with the final project. And then that final product, there's a few things. There's a GitHub. There's a PowerPoint, like a PDF, PowerPoint. There's a presentation. There's a write-up that you have that goes along with it, you know. So there's a lot of things that goes into, and there's a video. So a lot of things go into the final presentation that we'll be working on. So it's very important that you get that done. So with that said, in this particular project, there were 5 pieces. There's the schema, which came from the ncc.org. You guys will be working on enhancing the schema. You could decide, hey, I don't want to do breast cancer. I want to do colon cancer. That's a potential. Then I use the preview model 01 to figure out what all the connections were in that schema. I'll walk through this and explain this. Then I use that to build a synthetic data creator. And from the synthetic data creator, I could create a patient talk. This is where a patient can log in and talk to a clinician. Now, this clinician is an agentic. Okay, so there are 5 agentics that I created for this project. You can talk to that agentic, and the agentic will walk you through. And then there's a treatment model. We can go through and train this data, the synthetic data. And actually, when someone has a cancer diagnosis, they can come here and the doctor can use this to figure out what the best treatment for them would be. All right. With that said, in order to prepare this project, yes, there's a lot of research. I went out and got 6 certifications from the NCCN so I could understand what I was talking about. Once I did that, I pulled the schema from the ncc.org. And this is the schema, basically the column names, what was important to me. And then this is a scaled down set. So in this research today in your project, you're going to figure out, one of you are going to be figuring out, well, what are some better parameters to add here? You know, how can I beef up this schema, make it more diagnosis centered? And once I did that, once I had that schema, then I could go into my preview 01 model, asked it to connect the dots for me, figure out how everything in the columns connect and how they interrelate. And 01 did an incredible job of that. And once that was built, I was able to build a, in Hugging Face, and links are here in the slides, I was able to build an application that generates synthetic data. So let me show that to you real quick. So here's the application that builds the synthetic data. You can go all the way up to 1,000 data points. And it'll build two types of synthetic data for you. It'll build a clean and one with fuzzy, where it's been the noise has been introduced to give you more of an idea of real data. Now, let me go ahead and go here. If you want to know how this program is built, just hit Files, and you can go right to App. And in the app, it shows you all the code. So all this stuff is open to the public. You guys have full access to all of this. And you can write codes in Hugging Face. Hugging Face is free. Okay, with that said, we'll go back. And then let's go ahead and let's run it. Sorry. And so once you say I want 1,000 data points, so you can go ahead and hit Generate. And then it will generate that data for you. Let me open this up so you can see it. Once that data is generated, then you can download it. So here's the download, and we'll look at it real quick once it downloads. And there's your 1,000 patients right there, right there. I make the case for synthetic data later on in the paper, and we'll hit that. But synthetic data is going to become central in model training. And so one of the reasons we want to go out and find some good cancer data is so we want to take that cancer data and build a better synthetic model. What this model here has, it has the age and all the parameters in the NCC scheme, but also has the treatment. So you can actually train it against treatment. So if you're showing certain signs like a stage 3 positive, then this would be the treatment that you would need to proceed with. All right, with that said, that's the way that program works. Okay. And we'll say goodbye to fuzzy data for now. With that said, I just a few slides on this. Now, here's the case for synthetic data is that the alpha geometry it turns out that it has now hit, what they did is they went out and they created 1 million synthetic examples, bypassing traditional data limitations, enabling robust human learning without human demonstration. Let me explain to you what happened here. They wanted to go here and they wanted to try out alpha, to go against alpha geometry. And they wanted to see how well they could do in the competitions. So they didn't train it with human data. What they did, they had the system create synthetic data, and it began to solve its own synthetic data and create 100 million synthetic data examples, which it solved itself. And then it trained itself on what it solved. So it's kind of a self-thinking machine. So you're going to see as time moves on, the importance of synthetic data is just going to, skyrocket. I don't think we really understand how important that is. And this is what an important piece here is, creating synthetic data for this piece. I think there was someone had a chat here. Let me check real quick, see what that was. Says, will we only use synthetic data only for this? Not really. No, not necessarily. One of the assignments at the end of this will be, thank you for that question, Rima, will be for someone to look for real human data. And there are sources out there with real human data, and we can fold that into our training. So the idea is not to use real human data to make the predictions, but to use real human data to make your synthetic data better. Okay. So what we want to do, and I'm going to type that in here so you see that. We want to use real human data to make our synthetic data better. So it's just the opposite. What you might think. We're not trying to use synthetic human data to make predictions. We're going to use synthetic data to do that, but we want to use real human data to make our synthetic data better. So there you go. Good question. On the horizon, Microsoft has jumped into the mix and they've created something called Evidev, and the whole goal of Evidev is eventually, okay, and this is not part of this project, but eventually, this can be part of the business case though, eventually is to go from someone putting in their genome into an AI system which analyzes it and then creates a cure for that in a few days. So where you have to go through a clinical trial for 5 years, that's gone. Once you're in the quantum simulator, which will be coming, you'll be able to create real drugs, in just a matter of days and essentially cure people's cancers based upon their genomes. 2 cancer cases can look the same, but the treatment for one may help one person but hurt the other because the genomes are totally different. All right. So that's genomic data is a genomic data. It's the genetic data of the tumor itself. All right, with that said, next thing I did, once you had that synthetic data, and the better that synthetic data is, the better your predictor is going to be, I created a PyTorch treatment model. And so we can take a look at that real quick. Let me bring that up. So really, it's pretty much just a what's the word? A multidimensional regression analysis system is pretty much what it is. But I use PyTorch to run that, and Hamad, you probably have some knowledge of this. But if you want to see the code, once again, you can see all the data is here, and then the application is here as well, and you can see how it was written, okay? And pretty much uses a PyTorch model, and it keeps the PyTorch model in memory, and then it does the analysis in memory. And then what I have a training set, and then I have a test set. And so I run the test against it. I do it all on once in the program, just as a demonstration. So let me run that for you real quick. Here's the application. Here is the training set. And here is the in a sense, not the test set, because that's split off from the training set, but this is actually, in a sense, what you're going to go to implement against to see how well it works. And so what I do, you can browse and add files or use the files that are in there. You can change the hidden layer, you can change their learning rate, you can change the number of epochs. So if we go go down to 10 epochs, you're going to see you're not going to get some very good agreement. So now if I train it on 10 epochs, let's do that real quick. You can see the loss curve doesn't look very good. All right. And now I'm running it against my trial data. And you can see what comes out. But look at that confusion matrix and look at the accuracy and look at the precision, 0.57. That's not very good. So if you come along, and here you can see your confusion matrix is kind of all over the place. But if you come along here and now you're going to train it against 50 epochs, you're going to go 50 times with the data, get a really good training model. Then we're going to train it, and it will take a while. You can see you're spinning here and you're training. Here's your loss curve. It's done. It looks a lot better now. And you can see you've gone all the way up to your confusion matrix. Look at how that's lined up. Looks really good. And you're up to a 95% precision. Wow, that's really good. Now, you got to watch out, though, because you're going to overtrain a model. So you got to watch out about overtraining as well. But this is a demonstration of how it works. And so someone will be working on this, obviously. And so you guys can take a look at that. All right, so that was done. So with that said, we'll move on and see a comparison of loss curves just by changing epochs from 10 to 40. And I show you all the accuracy, precision, recall, and F1 score. And also I show how I show also the confusion matrix, how those improve. You can see pretty much a lineup here as you get to 40 epochs. All right, with that said, here's what comes out of this. All right, it's one of the first things is something I call everything talks. Here's where you have a strong business case. All right, so one of the things that you can do, because you have human intelligence in a box, okay, you can attach it to anything. So what I did is I created 5 clinicians. And so oncologists all the way down to a healthcare professional, kind of a treatment specialist as well. And I had all this data, and once again, this is synthetic data, it's not real data. And what I did is I said, well, wait a second. These clinicians can talk to the columns in the table, and they can talk to each other. So it turns out that these clinicians were in charge of a column or a group of columns that they would talk to and understand the patient condition. And then they would actually also talk to each other. But what made it even greater, the patient could log in and talk to clinicians about their case. And this is what's so powerful. And the reason that's so powerful is for a number of reasons. First of all, if you watch this video on YouTube, there's a discussion between these 2 doctors that brings this out. And that is that clinicians don't have enough time with their patients. And so you can have someone with a life-threatening condition, okay? And the clinician can only spend 30 minutes with them. What are you talking about? I might die. I need a day. I need a week to talk to you, right? To ask you all the questions that come up. Additionally, something very serious here. If you look at 106, what happens is some of the chemotherapy drugs, the OFS, ovarian suppression drugs, do things to people's bodies that really wreak havoc in their social lives. And they talk about this. And they talk about the fact that they really need to talk to somebody, but people don't have time to talk to them. They say, well, they need to find someone to talk to them. I go, who the heck do you talk to? Who is going to talk to you about this? And you may be embarrassed to talk to someone about it. But what this program allows you to do is to ask any question you want. And it has been beefed up to a vector database on that particular issue, on the ovarian function suppression drugs. And so you can come in and talk to them about your issues that are very personal, and you have as much time as you want with this vector talk, patient talk, to talk to the clinicians about your problem, your issues, and they can tell you everything about your cancer. And we're going to take a look at a use case and show you how it works. And you guys are going to be working on improving this system. So basically, what I created was called Everything Talks. And in Everything Talks, you have 2 vector databases, the patient data, okay? And it's also been beefed up on the OFS. And also you have 5 clinicians that you talk to. So let's bring it up real quick. So in this particular case, there are 1,000 cases. Okay, hold on. So there's 1,000 cases, and you go ahead and choose one of them. And so I would choose case 47. Okay, we're going to start here. Hit the start. And basically what it's going to come up and say is, please provide a patient ID. So we're going to say patient 47. All right, and patient 47 logs in. And what happens is says the name is Emily Harper, and immediately the oncologist brings up the chart and begins looking through the chart and the diagnosis, and talks about her lifestyle and gives some tips. It says, "Hello, Emily. How are you feeling today? I'm here to guide you through your care journey. Please feel free to ask any questions about your diagnosis, treatment, or any concerns you have. Together, we will navigate this step by step." Very compassionate, and so Emily might ask the question, "Tell me about my case." And so she could begin asking the doctor questions, yes, about her case. Because you have been diagnosed with invasive ductal carcinoma, which is the most common. And so begins to go through the case, talk about the sizes. It begins to walk her through, talk about surgery options, adjuvant therapy, genetic testing, lifestyle changes, stuff like that. Next steps, Yeah, and then just ask a very personal question: am I going to die? I mean, you can ask questions that you would not be able to ask about. It's like you might be and they may not have time, a regular physician, a regular clinician. They may understand how overwhelming and frightening this may be, and they begin to go on with the case, what this means to you. Yeah, can I talk to anyone else? And what she says is, absolutely. I mean, Dr. Anna Lee is going to come on, a risk assessor who specializes in evaluating prognosis based on lymph node involvement, tumor biology, and other factors. So there's other doctors that can come in and start talking to you about the case. And here comes Dr. Anna Lee. Hello, Emily. I know this is deeply emotional time for you, and I want to help you understand your prognosis. Now, I just burst into tears every time I read this because they're being so helpful, so kind, and so compassionate. And you guys can work on that as you begin to work through improving this system. So basically, that's an overview of the system. Gives the patient the ability just to talk all day, ask questions they would not. And I won't get into the personal issue of OFS, but that affects your personal life. And you can begin asking those questions about what's happening with me physically and why it's difficult for me with my partner. So I won't get into all of those, but you can see that. So let's see what we're saying. Rima says, will we only use, Rima says again, can you tell me a nutshell how this project is going to be helpful for breast cancer patients in the real world? These are clinicians. This is intelligence in the box. So they're examining your data, Rima, and they're talking to you. What this gives you two things. One, the ability to ask them any question you want as much time as you want. So one of the problems that happens with clinicians, they don't have time for you. They only got maybe 30 minutes in the office, and they got so many patients, they don't have time to talk to you. There's the ability to talk to them and find out all about your case. Okay. Find out if there's other options, and you know what I'm saying? So one of the things in your research, you might add other options, and you may have them basically give the ability to have other options. Maybe you want to try to do it another way. The other thing it does for you, it allows you to ask very personal questions that clinicians are not trained to ask, trained to answer. Okay. There are some clinicians out there that do not have the ability or skill set to answer very personal questions about what happens to a woman's body when they start taking some of these chemotherapy drugs. Okay. And that woman may either be very shy about asking those questions, or or the clinician may not be skilled in answering those questions, or just may not have time to answer those. And typically it might take a long time to get around to those questions. And so you have both: once patient information, the other is asking questions and these systems are trained to help ask those or draw out those questions. So you may, as you learn about this, okay, it's all in the documentation. As you learn about this, okay, you will understand some of those deeper issues. Okay. Okay. With that said, Rima, basically AI is doubling every 6 months in its capacity. So with the new reasoning models and everything else, it's just getting better and better. So if you have a problem with trusting AI, then that's maybe part of your project is working on getting that trust to work. But I'm telling you that if you start watching what's happening with AI, it's not like any other system we've worked with before. Yes, we've heard about hallucination, but that was a year ago. That's gotten better, but it's still hallucination. Yeah, it can do that. But once again, what you want to do is create a system that looks at what it just said and iterates on itself. So this is the preview 01 model, okay, used for this. So once again, those reasoning engines are coming. We're going from high school to college to PhD level systems. We're working on these reasoning engines. We're working on backflow. With that said, my research basically coming in 2025, I got a number of MIT and Stanford courses I'm doing because it's always about educating your self first and getting those concepts. Once you're in the 5 C's, the first is always a concept stage. I am the process of gathering, connecting data. This hackathon is part of that. Is pulling in data that might be needed. There is a precision med connection proposal. That's all the heuristics that go into deciding the cancer treatment that might be used. And of course, I'm building out the quantum systems for actually eventually going to where you actually can just put in your genomics and come up with a cure, like an EvoDip. Now, with that said, quantum computers are relatively new, but I am so surprised what they can do today. Just a couple of years ago, I was using 4 qubits, and now I have a system with 127 qubits, which basically can now enable me to do stuff that regular computers cannot do. So, I mean, I can't imagine what it's going to be like in 5 years, but at that sense, you're going to be able to build the quantum simulator. So this is a goal in the next 5 years, is to be able to put a genomic piece in there and to come up with a potential drug cure. This is a business case for quantum computer and genomics. It really won't be part of this hackathon, but you should probably see that. With that said, really at the end of the day, it's about drug discovery and precision medicine. You can go over through that if you'd like to. There's a number of systems out there right now that are getting pretty good. Fabric has a cloud system I reviewed. This will not be part of this project. And also medical data in Azure was also reviewed. You will not be using that. At the end of the day, ultimately, we aim to simulate molecular interactions, protein folding, and drug target binding using quantum systems to accelerate and develop the development of personalized treatment. That is coming. This is the precursor, like you're having your agentics talk to the patient data, and then you're talking to the agentics, and they're talking to you. And with that said, we are at the end here, and we're going to create some assignments, and it's for you to tell me what you want to do, what you want to work on. And so we're going to come back again in 2 days. We're going to have another meeting. We'll see how far you got and what you can get. So basically, there's the enhanced breast cancer schema. There's an enhanced breast cancer data set. There's enhanced the synthetic data creation. There's the diagram and enhance the patient talk. There's enhanced the model prediction, and there's the work on slides and business case or some other idea you might come up with would be amazing. Okay, so we got some questions. Okay, from the slide, 1, how quantum computer is related to breast cancer? I'm not able to find the connection. The connection is breast cancer that will not be part of this hackathon, but let me explain this to you, okay? Basically, what quantum computer can do is the problems that take you, a quantum computer, what will take 1,000,000 years to do, a regular computer can be done with a quantum computer in like 10 seconds. And so what it is, because these data sets are so large, and protein folding and all that stuff, how all this interacts to create personalized drugs really can't be done with regular computers. It will be with a quantum computer that you do it with. So simulating a molecular interactions, protein folding, and drug target binding becomes more feasible with quantum systems, accelerating the development of personalized treatments. So down the line, so this is all about personalized treatments, right? And so down the line, you'll be able to put your genomics in a quantum computer. You'll be able to analyze those and actually and come up with a treatment, potential drug. And that's what it is. It's the need for speed that quantum computing gives you, the ability, what would take 1,000,000 years to do it in 10 seconds. And since you're dealing with terabytes of data and these interactions of these 3-dimensional folding systems, that's the piece that it gives you too. Are we going to build a GPT, not a Streamlit app? We have both. Okay, so we'll probably show a Streamlit app, right, for the synthetic data piece, and we'll use the GPT for the patient talk. So we'll because we need the synthetic data to go into the GPT. Okay, so and I'm showing you examples, and we can take these examples and build them out and make them better. So pretty much this is a enhancement discovery project. Do you want to work on a better, and it doesn't have to be breast cancer. You could decide, hey, I want to do colon cancer. So whatever you guys want to do, but here's the project, and we only have a few days, so just remember that. All right, so let's go ahead and start choosing some numbers, what you guys want to work for. If you want to put it in chat, just give me the number that you want to work on, and I'll assign you to it. Okay. And once again, okay, look what we got here. So Rima she wants to work on number 2. Okay, great. All right, Ahmad's going to work on number 5.
Yes. Hello, Mike.
Hi.
Yes, sir. I appreciate your work, and you have done almost all things. I'm very surprised, and I would say that there were slides, and the fifth point I'm interested that to enhance talk model. Yes. So I'm asking that what I am supposed to do in that.
Well, what you do is the first thing you do is you would read the documentation on the model prediction. Okay. And then on
Uh,
the model prediction, Angelique's going to work on number 6. Good. On the model prediction, you would look at that and see if you'd have to take a look at the data and get better data. So someone needs to work on so you see if you can breast data cancer and see if you can enhance the synthetic. And once you enhance the synthetic, you might work on the treatment model. So it does flow down from 1, 2, 3, and 4, 5. But yeah, so you would work on that. Yeah. And some
uh,
of it's
uh,
just, and you might go, hey, I can do a better job of this. And you examine the system and see if you can make it better. All the information's in the document. I sent a document this morning. So if you read through that, all the information's there.
okay. I will tell you later after reading the. Sorry for surrounding voices. I am telling you after checking the documentation. Okay.
Okay, so let me go ahead and give you 2 things you need to look at. You need to look at that one, okay? And I also want you to look at give me a moment. I also want you to look at since you're thinking about it, also you should look at this one here as well. Okay, look at 3 and 5. Okay. All right. Same thing. Synthetic data creation folds into enhancing the model prediction. So those are important, both of those. Okay. All right. We got Belial. Which one do you want to do? And I think he disappeared. So we're going to make him an assignment. So if you're not here, you get assigned. All right. Let's go ahead and do that. All right. We'll put him on diagramming enhance the patient talk. Okay. There you go. All right. So I'm going to put some numbers here to make sure we got that. Now, Angeli, there's a lot of information already available, graphics and everything in the actual write-up itself. So you could actually use some of those. What you want to do is come up with a good business case on that. And right here we got 3 or 5. The reason I'm assigning you guys real quick on this is that because basically there's not a lot of time. So not a lot of time to think, but you want to get into it. All the documentation's there. This is very much research. Okay. So you're going to be doing a lot of research here. So that's how it goes. It's pretty much how it is. And actually try to come up with good ideas, new ideas. I'm welcome to new ideas. That's what you want to do. So pretty much that's the end of the presentation today and the assignments. You guys did a good job. It was a longer meeting. I like to keep it to 30 minutes, but a little longer today because it's our first kickoff. I'm very thankful for all you guys being involved in the project. And are there any more questions before I let you go? You need to go read that documentation. Angeli, start looking at this presentation and see if you can kind of, come up with something that looks good, come up with a good business case. And that's all I have. And we'll meet in 2 days and see where you guys are at. What do you think? So, Mike, I'm working on research, so it is possible that I write a research paper on this project. Absolutely. What do you think? Even though I'd be appreciative if it will work under your guide. Sure, absolutely. You can write a research paper on this. I'm more than happy for you to do that, Rima. Yes. And this is something I'm going to be working on for the next 5 years, Rima. So if you want to kind of pair up with me on this, feel free to do so. Because this is not going away. You're going to see more and more quantum computing as we probably not the next project, but the next hackathon I do will have some quantum computing in it. All right, good. Excellent. So guys, anything else?
Okay, Mike. So there's a question from my side. From
Yeah.
the point that I have chosen like enhanced model prediction, what I understood from it, like I have to enhance the prediction which are getting generated from the PyTorch model, right?
Yeah.
Yeah, I got it. Okay.
And then you think about it, do I need more real data? How do I make the synthetic data better? So it kind of flows all the way down, right? In addition, if you're into writing quantum computing, you want to suggest something about quantum computing, you're allowed to do that as well. What I'm looking for right now is looking at it, kicking the tires, coming up with better ideas, how can we enhance it? How can we make this better? Coming up with a really strong business case. Okay. Yeah, absolutely.
So when I was running your program, which includes a PyTorch model, I was a bit shocked because I have been working in deep learning. So I thought how a deep learning model trained in such a short time, because a deep learning model takes a lot of time to train, right? Then I checked it, like there was only one linear unit. So I got I think that's architecture of the model is very short. That's why it is not taking too much time.
Why don't you fix that for me, okay?
Yeah, I would like to fix that. But I think how is it possible? So I would say what are the ways I can fix it?
And all the data's there, so you can go generate more data if you need to, or add data. It's all synthetic data, so you have data to work with.
Yeah. So one thing I would like to ask, a model needs input. So are you going to change the synthetic data? Like, are you going to remove some input or add some input? Like, are you going to add some new columns?
I think in the long run, right? No one shows the enhanced breast cancer schema, but in the long run, this is a very short schema, and the reason it's short is to give you the conceptual, right? And to build out the conceptual framework. But really, what you want to do is enhance that schema. So in the long run, there's a lot there. You could easily have 50 parameters that you're looking at, maybe more. So I mean,
I'm talking about this project. So are you going to add some new parameter or like new features in the data set?
It would be nice to add a few, but for this project, we may be restricted to not doing that because we only have a short time. Because when you add them, you got to make sure they fit. There's a lot of work that goes into adding a parameter. I mean, a lot of research. And so basically, if you look at my timeline, what I'm talking about, in my entire semester, next semester, if you look at that, let me bring the timeline back up here. Pretty much what I'm going to be doing all semester next semester is working on that precision connection proposal. That's the heuristics of what needs to really go into this. What I have now comes from the NCCN is really good, but it's just like a short list. This I will give in April. I'll have the long list, and that will be all. And then we'll have the quantum computing set up, so we can start cranking this stuff in quantum computing. So yeah, so that's what I'm be working on. I'm actually in a class, a bioinformatics class, specifically to do this task. Yeah, and then I'll be pulling in more data, bringing more data. So you're going to see this pop up a few more times in the upcoming hackathon, especially as we move to quantum computing.